Good afternoon, everybody, and welcome to Citrix Analytics Under the Hood. My name is Matthew. I'm a platform product manager, and I'm joined by Jim, who's a data scientist.
Hi, everyone.
So, hi. So today, we're going to go over the mechanics of how analytics works. We'll talk a little bit about data protection, data governance, but mostly about machine learning and how we're using that to deliver insights to you. I know that I'm not the last guy standing between you and the beverages at the party, so I'm not feeling too guilty about it this time. Last time I was. So I hope you enjoy our presentation. So before I kick off, a quick couple of questions. How many of you are security admins or work in SecOps, InfoSec? Quick show of hands. OK, got one person. Couple of people. Awesome. And how many of you are on Workspace today? Citrix Workspace? Cool. A few of you. Excellent. I hope that by the end of this presentation, a lot more of you decide to start using Workspace. A quick thing, if you're all tweeting, which I wish you are, use these hashtags, and I'll get right in. So Citrix Analytics, for those of you who've probably heard about it, tried it a few times, this is essentially how it works. So all Citrix products have been instrumented to send events to Citrix Cloud. So any Citrix product which is a cloud service, some of the on-prem products as well, if you have hybrid rights, you know how that works. They all send events back to Citrix Cloud. Now, those events are processed using our AI and ML algorithms to provide insights back to you. So if you look at the top of the diagram, you've got security, performance, and productivity. So depending on which service you are using, you get different kinds of insights. So if you're in security analytics, you get security insights. You're in performance, you get performance insights. You're in operations, you see a lot of the operational data. So essentially, this is just control plane data that's being exchanged between your product and the control plane. So all that analytics does is it intercepts this control plane data, or this control data. We apply AI and ML to it. We look for patterns, we look for anomalies, and we provide you insights depending on which service you are on. So in today's presentation, we're going to dive a little deeper. So for a couple of years now at Synergy, I've been talking about how analytics works, but today we're going to dive a little deeper and show you how these things all come together. So let's start with the bottom. So there are three key concepts. So in every level, so we're going to cover 3 levels today, and at every level, we're going to cover 3 key concepts. So the first level is the platform itself. So there are 3 key aspects to it. We have turnkey data sources, which is the key concept I'm going to talk about. Then we look at the event and the event format. And then last but not the least, we're going to talk about vantage points and data sources. So let's look at how analytics works. At a very high level, analytics has some key services right at the top, right? But to get started with analytics, you've got to configure your data sources. So when you go to settings, data sources, and you turn on data sources, analytics makes an API call to the cloud control plane. It discovers all the analytics compatible products and services that you own, and then a product list is generated and displayed back in the UI. So the reason why we call it turnkey operation is because you don't have to worry about figuring out what your host names are, your site IDs, all of that stuff. You just click a button. We auto-discover all the services that can send data to us. You don't have to go figure out which services can send data to us. We take care of that for you. And instead, we display all of them to you as sidecars. So the first thing customers ask me is, hey, you do analytics. You seem to be hoovering up all my data. You seem to be analyzing it. What's going on? So the first thing I want to assure you is that we do not touch your data without your consent. So when you go to data sources, we discover all your data sources for you. Those data sources might be sending data to Citrix Cloud because that is essential for the functioning of those services. But analytics is not turned on by default for you, right? So what you need to do is go there, turn on data processing. When you turn on data processing, Citrix Analytics becomes ready to receive data that's coming from your environment. So it's not a pull mechanism. The Citrix products have to push data into Citrix Analytics. So when you turn on data processing, data processing turns on, and when your end users start doing something, data starts flowing in. And when that data starts flowing in, you're going to see these bar charts light up. But the key thing is you can turn off data processing at any time, right? So once again, Citrix Analytics is a turnkey service. You can go turn it on at any time. And when you turn on data processing, it's only then that we start processing your data. And the reason why we call it turnkey is because you don't have to go around installing agents and sensors throughout your environment. We just make API calls and we start receiving data because your products have been instrumented to send data to us, right? So that is key concept number one. The second concept I want to talk about is events. Now, after you've turned it on, or even when we have this discussion with customers saying, hey, you've got to go and turn on Citrix Analytics, the first concern they have is, hey, I've already got Splunk, it's super expensive, I'm sending them all my logs and traces. What does analytics do? Isn't that going to be expensive for me as well? The answer is no. So unlike other general purpose analytics platforms, we have custom instrumented every one of our Citrix products to send us events. So we are not pulling logs and traces, crash dumps, core dumps today. All that we get is an event that looks like that. It's encoded in JSON, and the event gets sent to us when an end user does something. So we are not receiving a constant stream of events at any given point in time. We only get an event when an end user does something. A typical event looks like that, encoded in JSON, and these events are extremely small. And because they're extremely small and because they're structured, structure is well understood by the machine learning algorithms that Jim is going to talk about, the system is also extremely fast and accurate. So that was a second concept. So basically, we are not hoovering up data from your from your environment. The events get sent to us when the end user does something, and the event comes to us as a JSON object or as a JSON payload. Now every event is about 2 to 3 KB. So do the math. If you have a few thousand employees doing something, we're probably going to be getting thousands, maybe millions of events every day. But because every event is just about 2 or 3 KB, the total data ingest is pretty low. So the last thing I wanted to talk about before I hand it off to Jim is vantage points. So the way to think about Citrix products is that they are deployed in key vantage points in your Citrix environment. So you have the workspace app or receivers running on people's endpoint devices. You've got the networking products all deployed in your network. You've got apps and desktops that are accessing your apps and desktops. You've got content collaboration that's looking at all your files. So basically, Citrix products are deployed in key vantage points in your environment, and all of them have been instrumented to send events back to Citrix. So basically, when an end user, for example, shares a file, we get an event from content collaboration, which used to be called share file. When an end user enrolls a device, we get an event from UEM, which used to be called Zen Mobile. So basically, you get this 360-degree coverage when you use Citrix Analytics because all your Citrix products are sending events to Citrix Analytics. We use these events. We consolidate these events to create user profiles. And that's what Jim is going to talk about. So just to conclude that section, basically, at the bottom, you've got turnkey data sources that send events to analytics. And these events are coming from key vantage points in your environment. With that, I'm going to hand it off to Jim, who's going to talk about user profiling and, most importantly, machine learning.
All right, thanks, Matt. So now that we've got these events coming in from the onboarded sources, we actually want to turn that raw data into something that's actually useful, right? Turn that into some kind of intelligence, some information that you can use at the business end of the product. So for security, we have a couple of main things here. We have user profiles, we have risk scores, and we have risk indicators. So I'm going to go through each of these. Now, the other thing, though, is that in this middle layer where the magic happens, that's also where ML lives. And it's not exclusively ML, but that is what we have in there. And I know it's kind of a slippery concept. If you're not a ML practitioner, you probably have an idea of what it is, but you've heard lots of different ways of describing it. So I want to be clear about how I'm going to talk about it. And hopefully I'll convince you that it's a good way to think about it in general, and you'll bring that forward when you hear about and read about ML in the future, not just today. So to do that, I want to go back to what's in my mind, probably the best thing we have as a kind of textbook definition of machine learning. And this comes from some academic publications from a decade or so ago, and you'll actually see a variant of this in the Wikipedia page for machine learning, if that's any validation. And it goes like this. A machine is said to learn with respect to a particular task if it improves its performance at this task following experience. Okay? A machine is said to learn with respect to some job if it gets better at that job with experience. So if you take some time to internalize this, I think you'll find that it's a useful statement, but I don't think that's easy to do, and it comes down to some of the language in here. So I want to do a couple of things before we move on. First, I want to take the word machine, which I'm telling you, I've been doing this for years, and I still think there's a part of my brain that conjures up an image like this when I hear machine and machine learning. Right? It just happens in my head, and it's distracting. So if this happens to you, or in any case, when you hear machine learning, mentally cross it off and replace it with software. Because certainly for any context that's relevant to folks here in the room or watching online, software is what we're talking about here. Secondly, the experience part. Personally, I find it hard to think about software or machines experiencing things, right? So if I go for a run on the beach wearing a smartwatch, I'm definitely experiencing that, right? I can feel the sand and smell the ocean air and feel that burn in my lungs, but is my watch experiencing that? No, right? What's happening is it's got sensors on it. The sensors are detecting things about the environment or my physiology and sending that as data, much like we've talked about with Citrix Analytics, to some processing center. So I think let's forget about the following experience thing and just say using relevant data, because that's what's happening. And then lastly, we'll take the learn verb itself. Again, you know, this is something we do as people, but it's hard to think about software learning unless you've already become comfortable with the concept. So we'll drop that part and just say apply ML, which leaves us with the statement that software is said to apply ML to a particular task if it improves its performance of that task using relevant data. And that's really it. So hopefully at this point you're thinking, well, that's pretty simple, but also that it's pretty powerful. And the other thing I've done here is take ML away from a particular set of techniques and tools and turn it into something that's a software capability. So ML is what you have when you have software that's capable of getting better at doing what it's supposed to do with data. And that's it. To do that, though, right, to actually implement something like that, you do need various techniques. You need algorithms. You need those methods. And this diagram here is not an exhaustive set. It's not a comprehensive taxonomy of machine learning. But these are all things that in our team we've researched, tried, experimented, and in some cases implemented. And again, not exhaustively, but things like various unsupervised anomaly detection methods, which is important for security. Deep learning, been very hot for a couple of years, can do powerful things. We've explored some things there. And then even statistical methods, which I put on here, and it might seem kind of quaint to talk about statistics in the modern machine learning era, but the fact is, if you're using the machinery of statistics to better understand some phenomenon in your data that allows you, say, to make better predictions, and those predictions lead you to some performance outcome that's measurably better with more data, then you're doing machine learning. Right? It doesn't matter that it's not deep learning. It's still machine learning. So the last thing before we get back to the product, I want to introduce the concept of a data pipeline. You may be familiar with this, but the basic idea is, well, we've taken Matt's diagram and just flipped it on its side. We've got raw events coming in from the left and going through some transformations and ending up on the stuff that you see in the product and exposed through APIs and does cool stuff for you. And the important part of this is that unlike, say, an oil pipeline that's just moving something around, in an ML or in a data pipeline, we're applying transformations along the way to turn this raw information into something more useful for some reason. So all of what we have in Citrix Analytics is built on data pipelines. I mean, this stuff is implemented in Azure, and we're using various big data technologies to flow this through. But fundamentally, again, this idea of having transformations of data along the way that do something useful is what we have underneath the hood. And I want to highlight that there are two different kinds of transformations. There are what I call the traditional, meaning non-ML ones, where the logic in that transformer is hand-engineered, right? It's written by a data engineer or a data scientist or a software engineer. And what it does is basically the same all the time until we go back and fix it and update it later. And we can do some really valuable things with that. But it's different from a machine learning capable transformation, where we're deploying a model or some kind of trained algorithm, which itself is adaptive and responsive to data. And it may be adaptive and updating as the data is flowing through, or it may be that, more commonly, there's some other kind of almost a separate pipeline. There's one pipeline where this transformation is being applied, and a second one that's got a learner that knows how to take some other data and use it to update what happens inside that thing. So you get this kind of dynamism where that transformer is changing all the time as a consequence of data, and that data is leading it to perform better. So how does that all fit in when we go back to Citrix Analytics? So we have these pipelines. In fact, we kind of have many parallel pipelines. It's not one linear thing. There's kind of a whole bunch of things that do different jobs. One of them is producing user profiles. This has no ML in it, but it's still super valuable. So what happens is events come through. We detect those. We see who those events are coming from. As we discover those users, we flow them to a page, and this is accessible through the API as well, that lists all of those discovered users and provides some basic information about them, like what types of data sources they came from, how many unique devices they've had, unique locations, and so on, over some specified time period. And then if you click into one of these, like Joss Carpenter here, third one down, you can go into Joss's page, go into the user info section, and see a little bit deeper information. If you have AD integration, you actually get directory information, which is really nice. You can see who Joss is, what their role is, provide some nice context for interpreting what they're doing, and a little bit of a deeper dive into the specific applications and devices and locations and the number of accesses associated with those. But now let's back out. We'll think more about security. We'll back out to a different view, which is Joss's timeline. So here on this timeline, we have specific security-relevant activities and events. And we call these indicators, risk indicators. It's a core part of the Citrix Security Analytics product. And the key thing to know about these, I'll go into some details, is again, they happen, they occur. We create them when unusual things happen by users, and they'll show up in this timeline. Once they show up there, you can click into them. Again, there's no ML here. We're just providing additional details that you can look at. So for example, if Joss has had access from a new device, you can go in and see what those devices were and when exactly this happened. The last thing on this page is the risk score. So that's in the upper left here. Joss is a high-risk user. Score is 98 out of 100. And I don't want to go into a lot of detail about the risk score, but the things you have to know are this. First, that these scores are unique to users, and the changes in those scores are unique to the users. That basically, when the user does risky and abnormal things, that score is going to go up. And it's going to go up kind of as a function of how many of those things they've done, the intensity of them, and how frequently, how close in time. So there are various kinds of ways that we amplify the score based on that. And then if the user thereafter doesn't do anything unusual for a while, the score is going to decay back to a normal level. So this provides you a way to know where to look in the first place, right? You don't have to dig around and look at all of your users. You can look through a structured view at the riskiest users and start there to investigate what they're doing. OK, so I said to hold off on the risk indicators themselves, so I want to take a few slides to go through these. And I've oriented them kind of around these 4 categories. That you're not going to see this in the product. We don't even really talk about this a lot within the team. But I think it's useful just to structure an understanding of different types of indicators from a simpler to somewhat more complicated along that kind of gradient. So we'll start with the simplest ones, the direct indicators of compromise. And these are immediately observable, security-relevant events and properties of events. So in Citrix Analytics, we don't have to do too much other than recognize when something happened. Like, for example, if Citrix Gateway has detected that a user's device has something strange going on when it's done an endpoint scan and sent us that failure event, we know it right then. We don't have to do anything else. Similarly, Citrix Access Control, based on URL reputation, tells us that a user visited a risky website. We get that as an event. Citrix Endpoint Management detects that a user's device has become jailbroken. Again, the logic happens there with the Endpoint Management product, and we get that as an event. So in all of these cases, we're able to pass that through. We don't have to do anything else. And what's nice is that sometimes it's just preferable to put that kind of logic, which itself may involve machine learning, on the product itself, and then inherit it through Citrix Analytics. Second are the derived behavioral analytics. So let me unpack that. When I say analytics, I'm talking about not the broad pursuit of analysis, but plural of an analytic, which is some intentionally computed thing to measure some characteristic, in our case about user behavior. And I say derived because you can't just look at one event and see it automatically. You have to look across multiple, often many events to measure this. And in addition, importantly, you have to have learned something about the user or the org or all users to contextualize that and make a determination about whether the behavior is risky. And that's where our learning comes in. So I'll give you 2 examples. One is unusual login locations, where we ask a few things. And when I say we ask a few things, the analytics is built to detect this stuff. First is a simple one of have you been here before? Right? So the learning is basically being able to keep track of where you've been when and have a kind of memory component so that if it's been 2 years, that's different from if it was yesterday. And then secondly, we ask, are you typically mobile? So if I always log in from my house, never anywhere else, and suddenly I appear from here in Atlanta, whereas Matt bounces around all the time and comes here, we'll regard my behavior as inherently riskier because it's unusual for me to move around. Additionally, we ask if this is a popular place in your org. So again, if I'm somebody who doesn't move around much, and I go have an event that comes in from the location of Citrix headquarters, turns out because we look at the behavior of the locations within the org, we can detect that that's not an unusual thing for me to do compared to showing up in a city that nobody from Citrix has ever had a login from before. So all of these things is what we factor in to the analytics and use to establish these thresholds of what kind of falls out of those bounds to flag as what would be considered an unusual and therefore potentially risky location for my login. Second example, very similar. This is with Citrix Content Collaboration, where we want to measure users who have excessive download behaviors, again, relative to their past download behavior. So we need to ask and track over time what's typical for a user, be able to kind of measure the distribution of normal download behavior, and have some algorithmic way to identify if somebody does something excessive compared to that, which may indicate a data exfiltration event. And additionally, we say, well, what's normal for the org? Sometimes we don't want to be in a case where if I download a single 5 megabyte file, and then 6 megabytes, and then 3 megabytes, and then 50, algorithmically by itself, that looks excessive. But when we contextualize what we see people do across the entire org, we see that that's not unusual, and we use that to adjust the risk score as well. So that's a secondary factor. So the third one I want to cover is what I call purpose-built attack detection. So far I've talked about things that are kind of about device or user security posture and some behavioral components that may indicate something suspicious going on, but they aren't detecting particular attacks. Now in this case, and the example that we have in the product today is around ransomware detection. We have some variants of this. We are specifically trying to detect if ransomware has occurred. And we do that with Citrix Content Collaboration. If your user has a sync tool enabled, and that sync tool is basically monitoring the files that end up getting hit by ransomware. Let's say the ransomware creates encrypted copies of those files and deletes the old ones. Because that's happened to the files, the sync tool is going to do the same kind of operations. And because the sync tool is one of our onboarded products, we're going to get events in Citrix Analytics. And so there's both a signature component of that. And we've actually learned this by creating sandbox environments where we've actually run ransomware and learned what a signature of the ransomware is in terms of the kind of synchronized patterns of spikes and uploads and download behaviors on those files. And that in itself is pretty cool. But it turns out if we then apply that to real data, users can do normal things that kind of look the same way. They're almost indistinguishable from that ransomware. So what we do on top of this is learn, again, what's normal for normal behavior for the user. Because what's actually really rare is for somebody to get hit by ransomware who also just happen to be doing things that kind of look like ransomware. So by combining these two things where we learn what's normal for the user in terms of upload and delete behavior, look for excessive behavior in those regards, and make sure that it matches that signature of ransomware, we can detect when things like this happen. And the data I'm showing here was from an actual case where we detected ransomware, a user who had a ransomware attack. All right, so the last one I want to talk about, I'm really excited about, and I highlighted its future and have our language at the bottom to emphasize that I'm making no commitment about when you'll actually see this in the product, in what form. But I will say that this is something it's not just an idea. We actually are running this kind of in the dark underneath and using it internally ourselves. And I'll call this kind of a more open-ended anomaly detection. So again, the previous three were all about something that directionally or just a priori we know is security relevant. Here we're almost just looking to see what falls through the cracks in terms of anomalous behavior. And to give you some intuition for how it works, take these 3 pictures here, which are all pictures of a person's face, 2 of which are real photos of real people, 1 of which is a fake, it's just a painting. And I'm sure every one of you can easily see that and recognize which one is the fake one. But if I asked you to write down some rules to tell me why that's the case, it would be hard to do. And if I asked 3 of you to do it, I bet you'd give me completely different answers. And if I then showed you 3 more pictures, one of which was fake, probably what you said would not apply to those 3. So how can we learn somehow in an algorithm that same kind of ability that we already have as humans to recognize this one that's different? So what we're using for this is it's one of the areas where we've been using deep learning. We apply what's called an autoencoder. It's a particular type of neural network where what we give it is not pictures of people's faces, but the behavioral versions of that, right? We calculate lots of things about user behavior over some period of time, and we do this for lots and lots of users, and we assume that the majority of that behavior is normal, because that's mostly what's in our data. If there's some weird stuff in it, that's okay. And we use that to train a particular neural network. And the structure of this, it kind of forces it to compress all that input into a smaller representation, kind of like a compression algorithm. And then you say, well, can we recover from that the original data? And it has to learn the right way to represent the things that best describe all these normal users. And it doesn't care about the fact that it can't describe other things. And then when you hand it a new piece of behavior for somebody who's doing something strange, we can actually measure that degree of anomaly in the output of this neural network. And so again, it gives us a way to kind of find these surprising types of anomalies. So we've done a bunch of this, and when we do it and compare it to users on which we've run our other indicators, what we found is that oftentimes there's overlap. Right? Ones that are anomalous by this particular algorithm are ones that for which we detected some of these other indicators, but sometimes it's not. And in the cases where it's not, sometimes when you go and look, you go like, that really was weird, but it's probably not security relevant. But other times, it looks like it may have been. So this is complementary to our existing ones, and what we're looking at now is what's the right way to expose this in the product to give you a different view of these other sorts of things that are at least worth looking at. That you can then go in and look at the events, do the searches, and do some of that investigation to decide for yourself if this user really is doing something that warrants some attention. So real quick before I hand back to Matt, 2 more slides. One thing is, what we don't have a lot of today is the ability to learn about what actually did result in a security incident, or more to the point, what things that we put in front of you as an admin looking at our output, where you agree and where you don't agree about these indicators telling us that something malicious is going on. So we have this, I think, only in 1 indicator now, but we're looking to expand out a way that we can have you report false positives, where you'll basically say, yeah, this location really was strange, or even more so, yes, this location was strange and it was a security incident, or it wasn't. So it gives us kind of a larger feedback loop ourselves to help improve the models. And then secondly, everything I've talked about is with respect to users and user risks, but there's more than just users out there. You have other assets, you have other entities for which there may be unusual, risky behaviors that you want to understand and monitor and remediate. And one we have in the product today is risky shares, again, with content collaboration. So if you share a file, we monitor what happens with that share link. And if things happen like an anonymous user downloads a file through a share link that was a sensitive file, we'll amplify some risk for that. And there's a whole portion of the product that gives you visibility into that and allows you to take actions on that share link as well. So with that, I'm going to turn it back to Matt to take it to the top.
Awesome. Thanks, Jim. Now, the last set of features I'm going to talk about, or the last set of concepts that I'm going to talk about, are the concepts that you will use in the product. These are features that you can configure. They appear in the UI, so we're going to look at services, actions, and search. So let's start with services. Oftentimes, when you listen to product managers talk about pricing, packaging, you're going to we use the word services, but we often tend to use those words a little interchangeably. So within analytics, there is a Citrix Analytics service, which itself is a framework, a platform, and then you have services baked into it. So you have security right at the top left corner of my screen. You have security, performance, and operations. So those are services. These services are essentially web applications that have been built on top of the Citrix Analytics platform. And the platform itself provides all the services like big data, AI and ML, governance, and so on and so forth. So these applications connect to the platform using an API gateway. So if you are on a call with one of us and someone says, which service in Citrix Analytics are you using, we're really referring to the services in the top left corner. So basically, there are 3 services today within Citrix Analytics, and then we're going to add more as we go. Now, the reason why I'm bringing this up is because as we start extending the platform, we will start providing APIs for third-party integrations. We are also going to provide other ways for US customers to get the data out. So today, there is a way for you to connect your SIM to Citrix Analytics and consume our data. We do that through Kafka, but there will be northbound APIs provided as well. So the whole idea is, and I think what I want you all to take away from this particular slide is that Citrix Analytics is a platform with services built on top of it, and we can integrate with third parties as well as with our other products, east to west and north to south as well. The second key concept, and this is something that I think differentiates us from a lot of other analytics vendors, is the ability to take action on the user for now, but then on any other profiled entity that lives within the service. So there are 2 kinds of actions. You can take manual actions. So today in security analytics, you can go to a user's profile, you can take action on the user. You can start session recording, you can log off the user, you can lock their device, things like that. So we call them manual actions. But in addition to this, Citrix Analytics also has a policy framework. So you can set up a policy to take action on your users. So how do actions work? So over here, I'm going to show you how the manual action works, but policy-based actions work the same way. So when you are in a user profile, over here I'm in Georgina's user profile, you see her doing something suspicious, you want to take action on Georgina, what you're going to do is click Actions and pick an action. In this case, I'm picking add her to a watch list, right? So I pick Add to Watch List and I click Apply. When I click Apply, what really happens is an action payload is created. So that action payload is created and put on a service bus. Now, all of Citrix Analytics runs on Azure, so the service bus is just another Azure component. We create the payload, put it on the service bus, and the Citrix products pull the action payload from the service bus. They've been configured to do so. So when they pull the action from the service bus, they examine the action payload and they decide on whether or not they can take the action. In most cases, they do. And when the action gets taken, the service, or which is the Citrix product that is sending data to Citrix Analytics, the service sends a status message back telling us whether the action succeeded or failed. The reason why we're bringing this up is because oftentimes when I talk about actions to customers, customers assume that there is some kind of a direct connection between the product, between the Citrix product and Citrix Analytics. There is not. We are not making direct API calls back to the product. There is complete isolation between the product and the between Citrix Analytics and the underlying Citrix product. They communicate through the service bus, right? Action gets created, gets placed on a service bus, gets consumed by the Citrix product, and after consumption, a status report comes back to us. Now, the third concept is self-service search. So Jim spent all this time talking about machine learning and how we abstract all the raw data from the user. And when I say abstract, it's really, we save you the effort of going through all the raw data. We save you from dashboard fatigue. The machine learning algorithms take care of analyzing the data and showing you alerts that matter to you. But if you want to investigate, if you have to investigate an incident, or if you want to further troubleshoot a user's performance problems in performance analytics, you need access to raw data. So this interface here is your access to raw data. Now, the first thing I'd like to tell all of you is when you try analytics, this is one of the first features I'd like you to try. So when you turn on analytics, you start doing things in the Workspace app, or you go to content collaboration, do something there, share a file, download a file. When you as a user, when your end users start performing actions, events start flowing into analytics, and those events all show up, all the raw events show up in search. Now, search is available in the top right corner of the analytics window. Now here you can run different kinds of queries. So you can run a Boolean query right here in that in the query window, or you can do a faceted search, or you can also toggle between the different Citrix data sources. If you've configured multiple data sources, you're going to see data per data source. And then last but not the least, you can export all of these results to a CSV. So one of the things customers often ask me is, hey, do I have access to my raw data? Can I go into your database and pull it out? As of today, we don't provide you with that capability, but what you can do is export it to CSV and then visualize it in any tool of your choice. But that said, if like some of you here are cybersecurity experts, you can actually export your processed events. So these are all the raw events. But you can export all the processed events like risk indicators, user risk scores, user profiles. You can export those to a SIM. So today we support Splunk. So you can send all of that to Splunk and then combine that data with all other data that you have in Splunk and create your dashboards. Now in future, we plan to support more SIMs, but as of today, we just support SIM, so Splunk. But coming back to this page, you have access to the raw data. You can search the raw data. You can query the raw data. And most importantly, going forward, we're going to have custom search and custom reports. So if you want to create weekly reports that you want to send to your management, this would be where you'd get those weekly reports from. That's pretty much all we had. And I'm glad to say that pretty much done. And you have just one more session to go before you go to the party this evening. But before you go, just remember the next session that I highly recommend is SYN201, which is performance analytics. It was a sold-out show yesterday. Apparently, we had 350 people. Clearly, we don't have 350 here, but performance definitely was a crowd puller. It's at 3:30, right after this session. And please tweet. Most importantly, also give us your feedback. Every time I come on stage, I've been coming to Synergy for 8 years, thanks to all of you. Please give us feedback. It's your feedback that makes these sessions better. So that's pretty much it from both of us. Thank you. And any questions, we are here. Thank you.